Hopefully you got to see the first video of problems 1 through 4, 2021 chapter competition in math counts. Now we're just going to look at 5 and 6. I have a feeling that one of those two might be a little bit more involved. All right, so the U.S. quarter is 0.069 inches thick. Clayton Kershaw, who tends to choke way too much in the postseason, earned $33 million for the 2017 Major League Baseball season. If Kershaw received his entire salary in the form of one entire stack of quarters, why? I don't know. What would the height be in miles? All right, I guess the companion question is, do we have that many quarters to make that happen? All right, there are 5280 feet in a mile. Express your answer to the nearest hundredth. All right, so here we go. This is just an arithmetic problem, should be pretty quick. All right, so we have 0.069, and that's a quarter. I'm going to multiply this by 4 so that I now know that, all right, and that's not visible. That's really not much help at all. All right. Let's see if I can turn this into something that I can actually see. How about black? There we go. All right. And then let's just make sure, okay, it's black moving forward. Okay. All right. So we know that this is the inches per dollar. Inches per dollar. All right, well then how many dollars is he going to get? Well, he's going to get 33 million of them. So I'm going to multiply this by 33 million. And so that means so this is now inches in his salary. Okay. Well, we don't want inches. We don't want to know how tall it is in inches. We don't know how tall it is in miles. Well, so I'm going to divide this by 12 inches because there are 12 inches in a foot. So this is the number of feet in his salary. Well, how many feet are there in a mile? So I'm going to now divide this number by 5280. It says how many feet in a mile. And so this is miles in his salary. And that's the answer. All right, since we have a quick one, we know we're going to have a long one. All right, here we go. And I got to tell you, I'm not satisfied with my explanation, but here we go. We have a rectangle that is, let's use a different color. How about orange? We have a rectangle. And we know that side AB is less than BC. So I'm going to go A, B, C, D. And then we have a diagonal, and that diagonal is going to be from A to C. And then it goes on to say that we have an additional segment that goes from B to A, and it meets at a right angle. And it doesn't give us any side lengths. Oh, that's a bummer. All right, so then it means the only way they can ask the question is a ratio, because I could apply a scale factor and make it bigger or smaller. So we're looking for a ratio here. All right. So then, so now we have 3 regions. They're triangles. I'm going to call the middle region M, because why not? I'm going to call this X. Just vertex. Love it. All right. And so it says there's an arithmetic progression. So this means this is a linear progression. So we know there's a slope, right? So I know that the middle is M. That means the smaller is going to be M minus my slope. That means the larger one is going to be m plus my slope. But here's the thing. I know that the two smaller triangles have to equal the larger triangle because the diagonal cuts the area in half. So therefore, we know that m plus s plus m, sorry, that's a minus, is equal to m plus s. All right, so let's do some math magics. I know that these m's are going to cancel out because they're on same side or opposite sides of the equal sign. I'm going to add s. So that means m is equal to 2s. All right, so what does that mean? That means if this is 2s, so if this middle one is 2s, then this would be 2s minus s. Well, s minus s is, sorry, 2s minus s is 1s. So really, we have the slope, we have twice the slope, and we have 3 times the slope. So that means there's a ratio of 1 to 2 to 3. Now, we also know that we have some similar triangles here, right? So we know that 1 and 2 are going to be similar. What's the ratio of similarity? Well, it's 1 to 2. And we know that AB is the corresponding side length. You know, this is the corresponding side length for CB in triangle CXB. Therefore, we know that AB over BC should be something like 1/2. But here's where I fall down on my explanation. It tells us that the ratio is going to be a common fraction in the form of square root of A over B. So my only move here is to put the square roots over everything. Because if you know, that would make more sense, right? So then we know that we have an irrational number in the denominator. You can't do that, so we have to rationalize the denominator. To rationalize the denominator, you're going to have to multiply square root of 1 over the square root of 2 by 1 in the form of square root of 2 over square root of 2, and we will end up with square root of 2 over 2, because square root of 2 times square root of 2 is just 2. And so that would mean my A is 2, my B is 2, therefore the value of A times B would be 4. And as luck would have it, that is the answer. So there you go.